Hello, mentors. In this video, we'll look at the counting for San Lorenzo and how we can generalize it. Remember, we have 5 flavors and 2 scoops. No syrup, no salsa, only the cone. So how many gelatos are there? And what if we had more flavors, like 1,000 or something like that? Let's take a look. First, for just the 5 flavors, students could do this, as we said, with the manipulatives, make this table just organically in the center and just make sure that they know which what each cell represents. So for example, this would be vanilla with vanilla, chocolate with chocolate. This here would be vanilla with pistachio. And then they would realize that it's the same as pistachio and vanilla because the order doesn't matter. So one way would be first count all the diagonals. And then say, okay, I only need to count either the top or the bottom diagonal. Doesn't really matter. So we could, for example, do this 6. This is the same. So you could put a 6 or just put nothing, whichever. 7, this is the same here, right? Vanilla and strawberry, it's the same as strawberry and vanilla, and so on. Any order is fine. 8, 8, and it's a nice mirroring exercise. 9, 9, so it's a mirror along the diagonal. 10, 10, 11. So this is chocolate with blueberry. Okay, it's here again, 11. Of course, this is very disorganized right now, but I'm just illustrating the point that it's an exploration. So you could lead with that, start with that. So 13, 13, 14, 14, and then 15, 15. So that's one way. But then you could say how we could count these faster. So there are several ways students could say, okay, it's just adding these numbers here, 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 and here. So it's a nice sum, 1 plus 2 plus 3 plus 4 plus 5. Let's write that. That's one way that students could think about this. Another way could be the following. And this could be good to generalize later. You have 25 from the start. But you remove the diagonal for now. So you get 20. And so they'll see that 20 represents all the flavors on the top or on the bottom, all the combinations of different flavors. But then you have to divide by 2. As we illustrated and we played with the material, so you would get a 10, right? But then you have to add back diagonal because those are really choices. So it's a 5 again. So it's a 10 plus 5. And so that would be the result, which is same as, 1 plus 3 plus 5. Plus 3 plus 4 plus 5. It's 15. Okay, so that gives us some expression, which would be this 5 plus 5, oops, minus 5, divide by 2, and then add 5 again. And students could factor the 5, for example, and they could discover that this is 5 times, right? So here you have a 5, and here you have a 5, so you factor it, and this would be 5 minus 1, which is 4. So 5 times 4 divided by 2 plus 5. And again, you could factor it or so. So there are several ways you could factor this 5. And here you would 4 divided by 2 plus 1, right? But 1 is 2 over 2. So this is actually 6 divided by 2. And this is a well-known formula that you could use. The point is that there are several ways to represent it. Just counting like this, adding like that, doing this process, or doing this factorization and arriving at either of these expressions. Let's do the 8 by 8. And of course, we won't be filling all the things, but more reasoning now with expressions and equations. So we would do the same, right? We would do 8 times 8. That would be all the cases. The diagonal is 8. So what you end up doing is 64 minus 8. Okay, so that's 56. And then you have to divide by 2, right? And then after you divide by 2, let's leave it for now like this, add 8 back. So it ends up being 56 divided by 2 plus 8. But 56, of course, is 8 times 7, right? Because this is 64 minus 8. So it's 8 by 8. So when you factor the 8, it's 8 eighths minus 1 8. It's 7 times 8. Or 8 times 7. And so the students start getting these nice formulas that are very flexible, that can look like this, or factoring the 8 again, right? As we did last time. 7 over 2 plus 1. But 1 is 2 over 2. So it's actually 8 times 9 divided by 2. But I mean, we're happy like this. We're happy if students even get something like this. That's already very good. What happens when you go to numbers like 1,000? Well, it's the same, right? So you don't do the table. You don't really make the table, but you think you have a big table of 100 by 100. And then you think again the same way. You have the diagonal. Let's do it again. 1,000 by 1,000 would be all. So you remove 1,000. So you would get this 1,000 by 1,000 minus 1,000. You would divide that by 2. And then you would add 1,000 again. And again, you could factor because everybody has 1,000 in this, right? So you could first do here 1,000, 1,000 minus 1 divided by 2, and then plus 1,000. But you could also, yeah, you could put it after there. So kids, yeah, I think it's important that kids do this not just with the 5 case or the maybe 8 case, but also with the 1,000 case, just to see what's going on. Let's take a look in more detail what we have here. So let's see, I am in this part, divided by 2. So what I have here is, yeah, I can factor 1,000 more here. So let's do it. 1,000 over 2 here, minus 1,000 plus 1, after factoring this one. And this minus 1/2 plus 1 becomes plus 1/2. It's a nice little trick. And then you factor it again. So divide by 2 here. And what's nice is that this is 1,000 plus 1. So you get this nice formula, and students can evaluate this because, of course, they'll divide by 2 here in this. So 500 times 1,001, which is equal to, okay, so 500 times 1,000 plus 100 plus 500 again. So they get 500,500. So I guess we get this number 500,500. Is a very nice number. You can check it here. We had these gelatos for the 1,000 flavors. If you want to go one step further with some of your students, or if they ask you, yeah. So we have to have high expectations. We would do it N by N. Let's do it. So what if we had N flavors in general? So again, this is optional for students that can already deal with algebraic expressions with variables. But you see the point, right? We didn't stop at 5. We went to 8 and 1,000, and we did some general reasoning. We talk about these actions. So this is algebraic thinking. So it's all leading into this. We don't have to end here in the N by N, but we're doing abstract, abstract, abstract all the time. Let's do it, N by N. That's the total. We remove the diagonal. And I think each time it's important to reconstruct the process of the flavor. So don't get too far from the gelato. Still think about the flavor. So we remove this. We then divide it by 2. And we also have to add N at the end. So this is the same. We factor N. So N minus 1 divided by 2 plus 2N divided by 2 if you want. So you have two expressions that have a division by 2, so you can factor that. And that's going to be, oh, sorry, and you also have an N, so N divided by 2, and you have N minus 1 plus 2. And again, the magic thing here happens. Minus 1 plus 2 is plus 1. So you get N times N plus 1 divided by 2. And that's really beautiful, because students would get this powerful formula that's just the number of gelato, right? Number of gelati if we have N flavors. So for 2 scoops. And that's a really nice formula. And then you can check it, right? Like with 5, it's just 5 times 6, 30 divided by 2, 15, which is what we got. And it all checks. Results don't matter, but they're just a nice way that when you reach them, it's in a nice way. It's because you had a good generalization process. You really got your hands dirty, started from the flavors and from the scoops themselves, from the manipulatives. You feel this table. You did these steps. You making sense of the expressions. And then when you're comfortable enough, you stay on the expressions, and then you put other numbers. And last step, optional, you go for full generalization. This is the number of gelati. Okay, hope you enjoyed this video, and see you in the next one. Goodbye.